So now we're going to take a look at solving a system by substitution. Okay, now these are two variables. We actually do get into three variables in a little bit, so just to distinguish between the three variable kind, this is two variables. When we have two variables, we cannot solve the equation unless we have another equation to help us. In other words, if we have two variables, we need two equations. We have one variable to solve, we need one equation. We have three variables we need to find, we need three equations to help us. So let's take a look at solving this by a process called substitution. The last video we looked at graphing, and this is now substitution. So when I'm wanting to solve by substitution, here's what I typically do. Now this is not I don't think it's written in any books anywhere, but what I like to do is I like to separate the two equations. Put one on one side of the paper and one on the other. So I'm going to do that here. And I'm going to look for a variable that's already isolated. Now a variable is already isolated. That just means that I have a variable that's already by itself on one side of the equals. And I find one. So if I find one, then I'm going to immediately swing from that place to the other side. So here I go. And instead, I'm going to write the equation that's on this side, but instead of writing the y, the variable that I found that was alone, I'm going to put in just a big fat parentheses and finish writing the equation. So now in the parentheses, I'm going to put what I found that y to equal. The y is 6x plus 50, so I put in 6x plus 50. Now I'm just going to go ahead and simplify, and I get this. Okay, and so I have 9x. I'm going to subtract 50 from both sides, and I get negative 45 on the right. Divide by 9 on both sides, and I get negative 5. Now, excuse me, we know that to solve the system means to find, if it's possible, to find an xy coordinate point that will satisfy both of the equations, right? So I've got half of my answer right now. I have a negative 5. I'm looking for the rest of it. So that means I need to swing back over. And because I know now that x is negative 5, I'm going to rewrite the equation, previous equation. I'm going to put in negative 5 for x. And then I'll be able to find my y variable. So that's negative 30 plus 50. And y ends up being 20. And there's my answer. Okay? So there it is. My solution is negative 5, 20. And if I put negative 5 in, here and put a 20 in here, it would definitely equal 5. If I put a negative 5 in here and a 20 here, then it would definitely check out, be equal on both sides. And then I would know that I'm correct. Let's take a look at another one. Now you notice that I don't have any graph paper. I'm looking at pictures. I don't have any idea what the picture looks like before I get the answer. Now once I get the answer, let's think about it. Once I get the answer, I know what the picture looked like. If we wanted to graph it, these would be intersecting, right, at one place. Okay, they would be graphed in such a way that they intersect at negative 520. So let's see what happens to this one. But again, because I'm using substitution, this is just my system. I'm going to write one on one side, one on the other. And now I'm going to swing. Okay, a whole lot of swinging going on. So now instead of writing the y, I'm going to put in what it's equal to and then finish copying the equation. So it says it's equal to negative 2/3 x plus 2. Now if you notice, the only kind of variable I have at this point on this equation is x, and therefore I'm going to be able to find x, right? One variable, one equation. Here we go, 2x plus, this is 3 over 1, it's going to be distributed. That's going to give me a negative 2x. This times that's going to give me a plus 6, and that's equal to 6. And then as I continue to combine like terms and just solve for x, look what happens. I'm just tooling along, minding my own business, and I get that. The variable has disappeared. Okay, so I'm going to write that in my notes here. The variable disappeared. Now that's really important. When the variable disappears, here's what I do. I draw a stop sign. I draw a stop sign for myself, and I say, okay, stop everything, stop, and I ask myself the question: Is the resulting equation true or false? In other words, I have 0 plus 6 is equal to 6. Is that a true statement? Absolutely true. So I circle true. And here's what that means. That means that I don't have to finish. I don't have to swing back over because the variable disappeared. I wasn't trying to make it disappear. It just happened in me doing my own thing. So if I have a true answer to the question, then this is my solution. Infinitely many, right? Infinitely many. So in other words, I know these are the same line. So here's why I would write that. X and Y such that, and I could put either equation on there, but I'm just going to show how the relationship exists between X and Y by putting an equation down. There it is. Infinitely many. Okay, and this is how I would show that. It means that X and Y such that there's that relationship between them, and as long as there's that relationship between them, then we have an infinite number of solutions. Okay, so this is how this is what you're going to find when you discover that these, to graph them, they would be the same line. Well, I'm not using a picture, so this is what you'll find when you end up with a situation where they are the same line. Okay, well, one more thing I want to show you. Let's go ahead and take this one, put one on one side, one on the other. Now this time I have two variables that are already isolated, and just for kicks I'm going to start with the X since I have a choice, but I just want you to know that it doesn't matter. You know, I don't have to start off with Y alone. So I'm going to go ahead and put a big old parentheses here and keep copying, and now I'm going to put in what that's equal to. Okay, here we go. Y is equal to, I'm going to distribute, and I get Y plus 8/5 minus 1. Okay, well I know that 8/5 is the very same thing as, what is that, 1 3/5? Okay, so 1 3/5 minus 1 is just 3/5. So I'm going to clean this up, and I have Y, I have Y is equal to Y plus 3/5. Get the Y's in the same spot, and look what happens. Whoa. Stop. Guess what? Quick stop sign. There's my stop sign. And I'm going to ask the question, look, the variables disappeared. I ask myself the question, is that a true or false statement? Is 0 equal to 3/5? That's quite false. Okay? That means that I don't have the same line here. What I have is parallel lines, meaning they're not touching at all, ever. There's never a place where they share an XY point. So I write no solution. And how do I write that officially as a set? I just write it this. That means null set. There is nothing in the set. Okie doke. Hope this was helpful. Thanks for watching.